Hello students, welcome to experiencetutor.com. In today's class we will discuss class 11th mathematics complex number part 9.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Straight line in Argand plane. First, the equation of a straight line in Argand plane is given by alpha conjugate dash or dash z plus alpha z dash plus c is equal to 0, where alpha is the complex constant, c is the real constant. Real and complex slope of the f line is equal to minus alpha upon alpha dash. Second, the two straight line with complex slope mu1 and mu2 are parallel and perpendicular accordingly as mu1 is equal to mu2 and mu1 plus mu2 is equal to 0. The straight line alpha dash z plus alpha z dash plus c is equal to 0 are parallel and perpendicular accordingly as alpha dash beta minus alpha beta dash is equal to 0 and alpha dash beta plus alpha beta dash is equal to 0. The equation of the line joining the point z1 and z2 is z is equal to tz1 plus 1 minus tz2, where t is a parameter. Fourth, 3 points z1, z2, z3 are collinear if z1, z2, z3, z1 dash, z2 dash, z3 dash, 1, 1, 1 are in matrix, are in determinant. The length of the perpendicular drawn from point z0 to the line alpha dash z plus alpha z dash plus c is equal to 0 is p is equal to modulus of alpha dash z0 plus alpha z0 dash plus c upon 2 alpha modulus. Remember, these points you have to remember like a formula. So I'm not wasting my time as well as yours and writing the formula again in front of you. So I have written the formula and the statement. Just go through it and try to remember this. The image z2 of a point z1 with respect to the line alpha dash z plus alpha z dash plus c is equal to 0, satisfying alpha dash z plus alpha dash z1 alpha dash z2 plus alpha dash z1 plus c is equal to 0, that is z2 is equal to minus alpha z1 dash plus c upon alpha. The centroid of a triangle with vertices z1, z2, z3 is given by z1 plus z2 plus z3 upon 3. The incenter is z2 minus z3 z1 plus z3 minus z2 z2 plus z3 minus z1 minus z2 modulus z3 upon modulus z1 minus z2 modulus plus modulus z2 minus z3 plus modulus z3 minus z1. Circumcenter z is equal to sigma z1 z1 dash bracket z2 minus z3 upon sigma z1 dash bracket z2 minus z3. Orthocenter of a triangle whose vertices are z1, z2, z3 are is given by z is equal to sigma z1 square bracket z2 dash minus z3 dash plus sigma z1 square bracket z2 minus z3 bracket upon sigma z1 z2 dash minus z2 z1 dash. These are all about the formula. Now the second section will start with circle in Argon plane. If a circle is drawn with z2 center and r as a radius, then the equation of the circle centered at z0 and radius r is given by z minus modulus of z minus z0 is equal to r, or z modulus of z minus z0 multiplied by z z dash minus z0 dash is equal to r square. And this implies that z dash minus z0 z dash plus z0 z dash minus r square is equal to 0. Which suggests that general equation of a circle in Argand plane is z dash minus alpha dash z plus alpha z dash plus c is equal to 0, where alpha is the complex constant and c is the real constant. The center of the circle given by above equation is minus alpha, and the radius is under root alpha dash minus c is equal to under root alpha square minus c. Third point, the equation of a circle with z1 and z2 as ends of one of the diameter is z minus z1 bracket z dash minus z2 dash plus bracket z dash minus z1 dash bracket close black bracket z minus z2 is equal to 0. Point number 6. The equation of a circle passing through three given points z1, z2, z3 is given by z dash z dash 1, z1, z1 dash, z1, z dash, z1 dash 1, z2, z2 dash, z2, z2 dash 1, z3, z3 dash, z3, z3 dash 1 is equal to 0. This is the equation, which can be further simplified to z minus z1, z3 minus z2 upon z minus z2, z3 minus z1 is equal to z dash minus z1 dash, z3 dash minus z2 dash upon z dash minus z2 dash, z3 dash minus z1 dash. Hence, it can be concluded that the 4 points z1, z2, z3 and z4 are consecutive if z1 minus z3 z2 minus z4 upon z1 minus z4, z2 minus z3 is purely real. Point number 5, the inequality R is less than modulus of Z less than capital R represents the annals space between two concentric circles centered at origin. Sixth point, R is less than equal to 1 less than equal to z minus z0 modulus less than equal to capital R represents the closed disk. Now let us study important of loci in Argand plane. The locus of a z satisfying z minus z1 modulus is equal to z minus z2 modulus is perpendicular bisector of the line segment joining points z1 and z2. Point number 2, the locus of z satisfying z minus z1 modulus plus modulus z minus z2 is equal to modulus z1 minus z2 in is the line segment joining z1 and z2. The locus of z satisfying z minus z1 minus z minus z2 modulus is equal to z1 minus z2 modulus is also a straight line joining z1 z2, but z does not lie between z1 and z2. If argument z minus z1 upon z minus z2 is equal to 0 or pi, then the locus of z is a, the straight line passing through z1 and z2. Point number 5, the locus of z such that z minus z1 plus z minus z2 is equal to z is equal to 2a, where 2a is greater than z1 minus z2 is an ellipse having foci at z1 and z2 and a. The locus of z such that modulus z1 minus z minus z1 minus z minus z2 is equal to 2a, where 2a is smaller than modulus of z1 minus z2 is a hyperbola having foci z1 and z2 and a. Point number 7, the locus of z such that modulus of z minus z1 upon modulus of z minus z2 is equal to k is greater than 0 and k is not equal to 1 is a circle. The locus of z satisfying z modulus of z minus z1 square plus z minus z2 square is equal to k is a circle provided k is greater than equal to half z modulus of z1 minus z2 whole square.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.